students, in the previous video I had started pseudo force, right? I will solve some examples pertaining to pseudo force and applying the concept of pseudo force. First question is this: you see, this is a trolley. From the roof, one mass was hanging. When it was accelerated, a certain acceleration A, then mass is moved at an angle theta with the vertical, right? So I have to find the acceleration as well as the tension in the string, tension T, isn't it? So in two ways this problem can be solved. One, when the observer is inside the trolley. Second, when the observer is outside the trolley. The first case I consider when the observer is inside the trolley, because the concept of pseudo force we have to apply. Suppose the observer is here, right? Observer is here and he is observing this bob and trolley is in motion with acceleration A. Since the trolley is in acceleration, the system, if we consider this as trolley, it is in acceleration. That is why this frame is the non-inertial reference frame. Because as per the definition, with respect to ground, it is earth. With respect to earth, if any frame is accelerating, that is non-inertial reference frame. So this is non-inertial reference frame. An observer is there in non-inertial reference frame. Therefore, one pseudo force will have to be considered on this. If the mass of A is ma, then pseudo force will act and direction of pseudo force will be opposite to the direction of acceleration of the reference frame, minus ma0 in the previous video if you look at. So minus means the opposite direction of the direction of acceleration. So we will say that a pseudo force is acting in this direction, that is, if the mass is ma, then it is ma into A. Acceleration in this direction, pseudo force is acting in this direction. Now, if we make FVD, then weight is acting, mag downward, the pseudo force, and this is the tension in the string. And since with respect to this observer, this will be at rest, because system is, this whole frame is moving with acceleration A, he is also moving with acceleration A. He will say, with respect to me, this bob is at rest. Right? When this system is at rest, it means net force acting in x direction as well as in y direction should be 0. So suppose we select this is x direction and this is y direction. So what is the condition? Sigma fx must be 0 and sigma fy must be equal to 0. This is the condition for equilibrium of an object. When equilibrium is, it is at rest with respect to observer. Observer says it is at rest, means net force acting on this must be equal to 0. C. Then we will resolve this tension in these two directions, because this is along x-axis, this is along y-axis, only t is in different directions, so we will resolve this tension in these two directions, x and y. So this is theta, this will also be theta, these two are parallel, this is transversal, alternate angle, that will be geometry. Alternate angle, this will also be theta. So it is t cos theta will act in this direction, t cos theta, and in this direction, that is t sin theta. Means t sin theta is this direction, ma is this direction, therefore t sin theta is equal to ma into a, right? And t cos theta is equal to mag. These two relations we got as per the condition. Ma is 2 kg, theta is 30 degree, and g is 10 meters per second square given. Therefore, T sine 30 degree is equal to 2 into A, and T cos 30 degree is equal to 2 into 10. We will divide first equation by second equation, that is first and that is second. Therefore, sine 30 degree upon cos 30 degree is equal to 2a upon 2 into 10. 2 and 2 will go. This is tan 30. Therefore, tan 30 degree is equal to a by 10, and tan 30 is root 3. Therefore, 1 by root 3 is equal to a by 10. Therefore, a is equal to 10 by root 3 meters per second square. This is the acceleration of the trolley. We want t also. Therefore, from equation 2, t cos 30. Cos 30 is root 3 by 2 is equal to 10 into 2 is 20. Therefore, t is equal to 40 upon root 3 Newton. So, value of a and t we got, considering the observer is inside. Right? Means observer is non-inertial reference frame. This is a non-inertial reference frame. Another way of solving this question, when the observer is outside the frame, this is the non-inertial frame, observer is on the earth, earth is an inertial frame of reference. Now the observer is in inertial frame. Previously it was in non-inertial frame of reference. So we got some result. We will see that with this concept that the observer is in inertial frame of reference, result will be same. And see, since it is moving with the acceleration a, this point will move forward and this will remain as its place, then shape will be something like this. There will be strings, will be something inclined, right? It is just because of inertia. Ball was hanging, it moved with the acceleration, this point moved. By inertia it tried to be at its place, means it will get inclined somewhat, right? Suppose this angle is theta. So tension will act, mg will act, FVD if you are making, tension here, mg here. So with respect to this observer, what he will say? He will say that this bob is moving with the acceleration in this direction. Because this trolley is moving, so observer will say this bob is also moving with this acceleration. So when it is moving with certain acceleration in this direction, so there must be some external force acting on it. Some force must be acting which will make this bob to move in this direction with the acceleration. Unbalanced force is needed. What is that unbalanced force? Which will create acceleration in this as per Newton's second law, isn't it? So that unbalanced force we have to find. See, this is the tension, this is downward force, mg is acting. Now we will resolve this force in two directions. In this direction t sin theta, in this direction is t2 cos theta. Pseudo force is not acting for this observer, right? Now if we see the forces, t cos theta is balancing mag. So we can write therefore t cos theta is equal to mag. It is getting balanced because there is no motion of the bob in vertical direction. Observer will say bob is moving in this direction only. So net force along y-axis, that will be equal to 0. This t cos theta minus mag, that is equal to 0, or t cos theta is equal to mag. This t sin theta is unbalanced force, and unbalanced force causes acceleration, isn't it? Therefore we can write t sin theta is equal to ma into a. It is by Newton's second law, that unbalanced force on an object causes acceleration, and that is net force is equal to mass into acceleration. That I have done. Net force along this on this object, it is acting in this direction, t sine theta is the net force acting on the bob in along x-axis. So acceleration will be created along x-axis. That acceleration is a. Observer will say it is moving with the acceleration a. Mass is ma into v. This relation we got. If we put the values by this method also, when the observer is in inertial frame, we got the same relation. So result will also be same. Therefore tan theta is equal to a by g. This divided by this divided by this. Therefore a is equal to g tan theta, that is 10 into tan 30 degree, that is 10 into 1 upon root 3. Therefore a is equal to 10 upon root 3. And by putting the value of a, we can get the value of b also, or simply put the values given in this. This is equation number 1, equation number 2. So this is acceleration we got from 1 t cos theta, that is equal to mag. Therefore t into cos 30 degree is equal to 2 into 10. Therefore t into cos 30 is root 3 by 2 is equal to 20. Therefore t is equal to 40 upon root 3. This is this much Newton force will act, and this is meters per second square is the acceleration. Same result we got, but concept was different. Here the observer was inside the trolley, that is in non-inertial reference frame, and here observer is in inertial frame of reference, that is on the ground. I will take another example. Now this is second question. Question is such: this is a wedge. A mass A is kept on this, and its mass is 3 kg. What should be the acceleration of the wedge, so that with respect to wedge A will be at rest? What should be the acceleration so that with respect to this it will be at rest? Isn't it? So see, with respect to this I want, means this is a non-inertial reference frame. With respect to this means, suppose observer is standing on this. Observer is here, is standing on this wedge. So with respect to wedge, this mass should be at rest. That is the condition. So his observer, this is wedge, and that is non-inertial reference frame because it is in acceleration. So observer is standing on the non-inertial reference frame and he is observing the object, and object should be at rest, means whatever forces are acting on this, those forces should be the balanced forces. The net effect of that force should be 0. Now you see, what are the forces acting on this? mg is acting downward, that is mag, right? And on this, due to this wedge, reaction, normal reaction will act, right? And since the observer is in non-inertial reference frame and he is observing the object, naturally I will have to apply a pseudo force on the object, then only the result will be as per Newton's second law. So a pseudo force will act in this direction, that will be ma into in opposite direction. This direction is acceleration of the mass. Wedge is moving with acceleration, this is also moving with the same acceleration. So a pseudo force is acting on this, right? So these three forces acting on the mass and net force must be equal to 0, right? So we will resolve these forces in the two perpendicular directions. Suppose this direction I have chosen as x and this direction is chosen as y. So we can resolve this force. And because this is along x-axis, this is along y-axis, resolution of these two is not required, and resolution of this is required. This is neither along x-axis nor along y-axis, so this will be resolved. See, this is 37, this will also be 37, this will also be 37 degree, right? So now we will resolve this normal force, that is n cos 37 in this direction and n sin 37 degree along x-axis. Since he is saying that it is rest, so these forces must be balanced one, as I said. Therefore, n sin 37 degree is equal to ma into a, and n cos 37 degree, that is equal to mag. So from these two, we will divide, we will get tan 37 degree is equal to a by g. Therefore, a is equal to g tan 37 degree. Here, g is equal to 10 meters per second square. And suppose normal reaction is to be found out, that too we can find the normal reaction also. So here from this we will get a is equal to 10 into tan 37. So for 37 it is standard angle, this is 90 degree, this is 37 degree, then this is 3, this is 4, and this is 5. So tan 37 is 3 by 4, 3 by 4 we get. So that will be 30 by 4, 7.5 meters per second square. Therefore, A is equal to 7.5 meters per second square. This should be the acceleration, then with respect to which the mass will be at rest. We can find the normal of n cos 37. That is n cos 37 degree is equal to mag. Therefore, n into cos 37 is 4 by 5 is equal to ma. Ma is 3, right? So 3 into 10. That is n is equal to 30 into 5 by 4. That is 150 by 4. That is therefore n is equal to 37.5 Newton. This we got. So we got the normal reaction as well as acceleration of the wedge. Now see the same problem, but the observer is in inertial frame of reference, that is on the ground. Since the observer is in inertial frame of reference, pseudo force will not be acting on this mass A. Got it? That is why this force will not be there. But the normal force will be acting. Normal reaction force due to which it will be acting perpendicular to the surface of contact. This is surface of contact perpendicular to this. This normal force always acts perpendicular to the surface in contact. So these two forces will be acting according to the observer, this and this. And these two forces, net force will cause the acceleration in this mass. Observer will say that this mass is moving with acceleration A in this direction, isn't it? So only these two forces are there. So net force resultant of these two will be in this direction, which will cause the acceleration in this mass. It's very important. Every time I am giving the solution in both the ways, when the observer is on the non-inertial frame and when the observer is in inertial frame. Application of Newton's second law. In both the cases, same equation will be framed and the result will also be same. That is the concept behind it. So to find the resultant, we will resolve normal into perpendicular direction along x-axis, along y-axis. So y-axis there is no motion, so these force will be balancing. Only unbalanced force is n sin 37. This force, the net force along x-axis, will cause the acceleration in the wedge or on the mass because it is in contact with the surface, right? Therefore, after resolving, we are getting n cos 37 degree is equal to MAG. And the unbalanced force, this one, this is unbalanced. That is unbalanced force. This is not balanced one. So this is a net force or net force. Net force is along this direction and net force will cause the acceleration. Therefore, N sin 37, that is equal to MA into A. You see, results are same. Equations formed is same, but the concept is different. So I am concerned with the concept because result has to come same as that of the previous case, but the concept used altogether different. That I want to make you understand. So this is the relation we got, same relation we got. Therefore, in the same way, relation result will come. This divided by this, again tan 37 degree, that is equal to how much? A by G. Therefore, A is equal to G tan 37 degree. Again 10 into tan 37 is 3 by 4, that is 30 by 4, that is equal to 7.5 meters per second square. Therefore, A we got, that is 7.5 meters per second square, and we can find the value of N also using this equation. So I think concept of pseudo force is clear to all of you. Its application is clear. You can solve number of problems. If time permits, then I may take up more and more problems on this. So I will meet you once again. Till then, all the best. Take care of you.